Hi, thank you for joining us to learn more about MIT System Design and Management and our current call for proposals. My name is Ben Linville-Engler, and I'm the Industry and Certificate Director for the SDM program. So today, I'm going to share with you some information about MIT SDM, if you're not familiar with the program, or who we are and who our students are. And then we'll talk about the Core Integrated Team Project, as well as some expectations for both the project sponsor as well as the student team, and discuss how you can submit a proposal for this open call. And then we'll address some frequently asked questions. For those of you who aren't familiar with MIT System Design and Management, let me tell you a little bit about who we are. MIT System Design and Management is focused at solving complex challenges at the intersection of engineering and business. We were actually founded in 1996 in collaboration with industry when companies came to MIT looking for a program to help educate the future technical leaders of tomorrow. MIT SDM takes a holistic approach that enables students to become technically grounded leaders. We're a joint program of the School of Engineering and the Sloan School of Management, and we further developed experienced technical professionals to enable them to lead effectively and creatively. We do this by taking a systems thinking approach to multidisciplinary problem solving, model-driven engineering, design, and strategic decision-making throughout the entire life cycle of a product or system. Now I'd like to tell you a little bit about who this year's students are that you may have an opportunity to work with. As I mentioned, we focus on mid-career professionals. So on average, our students have 8 to 10 years of work experience, typically from a technical background. Our program very much has a wide diversity of both life experience as well as professional experience. So we have students from about any industry you could think of, or just about any technical background that you could think of as well. We also have students that already come into the program with master's degrees, which account for about 50% of our current students, and some also have already obtained a previous PhD. Our program also has students from both the US as well as outside of the US, with on average about a 60-40 split, depending on the year. So where do we fit in at MIT? As I mentioned, we're really at the intersection of business, engineering, and technology. And so what that means is that we have access to courses, faculty, and other engagements at both the School of Management as well as the School of Engineering. As I mentioned earlier, we were also founded at the request of industry, and we have maintained a close connection with industry throughout almost the 25 years that we've been operating. And it's really important for us and our students to maintain that connection because we really operate at the boundary of research and implementation. We want to take the research that we have, but how do you act on that research, especially when you're solving complex challenges? Lastly, MIT is really a magnet for creative, technically driven, intelligent people, and that is a really key aspect of the opportunity that our students have, as well as community members or project sponsors. So where do we play? Solving complex challenges at the intersection of engineering and business really does take a systems thinking approach. And in our core course, for which this project call is about, we take that systems thinking approach and we look at it throughout system architecture, systems engineering, and project management. And the way that the program is designed is that we go through this process a number of times to understand the interconnectedness of these topics and how they relate to one another throughout a project lifecycle. So what that means is that we look to help our students not just think about being problem solvers, but problem seekers, and understand the entirety of the problem space, both from a business value and strategy standpoint, but also from a technology and engineering implementation standpoint. And what are those relationships that exist between different aspects of the problem that you're solving? Ultimately, this enables us to identify the full design space and subsequent solution space so that we can understand the design decisions that we're moving forward with and what are the trade-offs that we're making decisions about. So I've mentioned systems thinking a few times, and a quick way to think about it is really to put it in terms of human connected design. Connected with one another, connected around the globe, connected with technologies, products, and services, But really, what are those relationships that exist, and how do you define value based off of those relationships or interfaces? So it is a holistic way of thinking. It's also a great way to actually learn about new problems, new industries, markets, or technologies. It's about the relationships that exist between aspects of the system, and ultimately, how do they connect to form new functions, but also determine what emergent properties may exist in coming from these. The other piece that I've talked about is systems engineering, and this is very much about multidisciplinary teamwork and implementation. And there's a number of different implementation frameworks that you may be familiar with, but for us, from a technology architecture and product architecture standpoint, we really focus on form, function, and frequency are often called operations of a system. Again, this is thinking about how to implement across disciplines, maybe across industries. And generally, there's some sort of disciplined process that exists for the implementation of this, whether it's deconstructing the high-level system requirements into detailed design work. How do you think about verification and validation procedures? There's some structure to the implementation method that you look for. But also what's really important is that we take into consideration the uncertainties that exist throughout the product lifecycle, both from a business and a technical standpoint. So what is the Core Integrated Team Project? Here's a quick overview slide. So if you want to just stop here, you're welcome to. I'll continue into each of these topics in depth. But from an overview standpoint, we're very much looking to solve complex challenges with a systems approach. There's a number of different types of projects that we look for our students to undertake during their spring semester. It could be integrating a new technology into an existing product, maybe bringing promising new technology from the lab to the market, investigating a troubling or dysfunctional product or part of an organization. But also you can look to evaluate a historic case study to understand more about why it was either successful or unsuccessful. A few of the key dates that we're looking at is we're looking for initial drafts of the project proposals to be submitted by November 20th, and we'll continue to work with you on refining those before January. We will be having our sponsors pitch their proposals to our students in the second week of January of 2021. And the student teams will form shortly thereafter and continue to work on the project from February to mid-May, at which point we'll have final presentations and other events. In total, for a sponsor, we're looking at roughly 24 hours of total commitment. A few hours up front here to develop your proposal and work with us to refine it. And then on average, about 1 hour per week to provide teams with guidance. It really is dependent upon how you and your team want to communicate. It could be once a week, every other week, it just depends. And then also we do look for final feedback on the project outcome. For any questions, feel free to reach out. My contact information is listed there. And if you're looking to submit project proposals, we'll have an email for you at the end of this video. So there's a number of great benefits in sponsoring a project. First and foremost, it's an opportunity to work with a talented team of SDM fellows who are mid-career professionals and come from generally a technical background of many different industries. There's no fee to pitch a challenge or to continue to have your project worked on if a team selects to work on it. This is an opportunity for you to see how a systems thinking approach applied to systems engineering could benefit your organization or your types of projects, and get an introduction to some of the methods and tools and ways of thinking in which SDM and our students pursue. In addition to the project, this is a potential for internships or full-time roles that may come after as you get introduced to some of our students. And also it's a great way to connect with the MIT SDM community. Typically during our kickoff and follow-on events, we do invite in alumni as well as the other industry sponsors. And so it's a great way to network. And lastly, there are opportunities for follow-on research or other engagements with SDM, which may come from this as well. So a quick project overview. As I mentioned, our project sponsors will be presenting their project challenges to our students in January. Historically, we have had sponsors come on campus. However, this year we are making virtual accommodations so that we can have an engaging event both to present the challenges, but then also enable our students and sponsors time to connect and talk about the topic in more detail. This is a great way for our students to learn about different companies and also for companies to learn about our students. Shortly after the presentations, the teams will start to vote and form based off of what they're interested in working on. And then following quickly in January, there'll be a series of intensive workshops for the student teams to kickstart their projects. The students continue to work on these projects from January to May and ultimately culminates in a final project presentation to SDM faculty, instructors, and the sponsors, as well as others across the MIT. So generally there's 4 types of projects that we find to be a really great fit for our students as part of this core academic experience. The first one could be bringing a new technology from the lab to market and understanding what dependencies exist both from the market side, but then also the product and technology side, and understanding what that ultimately might look like from an implementation plan. The second may be actually introducing a new technology to an existing product. Like, what's the existing product and architecture? How might you integrate the technology or technologies as they become ready? A third project topic is actually to evaluate and investigate a particularly troubling or dysfunctional product, service, or organization, and how might you actually improve upon this? A lot of times these serve as great ways for students to deploy different methods and tools that we encourage them to use. Lastly, a number of sponsors will pitch historic case studies of a project or program that was either particularly successful or unsuccessful because they want to learn and find some key interesting opportunities of how they may approach similar or different problems in the future. So a deeper dive into some of the project requirements. We're looking for challenges that are non-trivial and involve some level of socio-technical challenge. This could include significant societal, technical, or programmatic challenges for an organization to pursue. In addition to this, I've mentioned before, but there is no fee for sponsoring a project or pitching the project. This is an academic focused project. It's part of the student's academic experience. And so this is something that we're really looking for the students to be in the driver's seat. And as such, this is not a project in which you can pursue an NDA or other proprietary agreements with our students. They are very much in the driver's seat. We're looking for you to provide guidance in terms of your expertise and your stakeholder perspective. However, the students will potentially take this into a direction that you maybe didn't anticipate. I mentioned the 4 types of projects that we think are a good fit. Currently, we're not looking to engage with projects that are consulting in nature, maybe include organizational design, process improvement, or portfolio pruning projects at this time. As I mentioned before, students are going to ultimately vote on which projects that they're most interested in working on. And what that means is that not all proposals are selected. Students vote on their top 3 preferred challenges, and from that we form teams of 4 to 5 students. Last year, for some context, we had about 35 different projects pitched, and we had enough student teams to field 24 of those projects. As you can see, topics range domains across security and safety, domain, transportation, energy, health, manufacturing, and many others. For a specific look at who our project sponsors were for 2019 and 2020 and what those topics were, you can take a look at the chart here. The company Danfoss sponsored 2 projects, one focused within manufacturing. Otis, and we'll talk about this a little bit later, was pursuing a ropeless elevator design. We had a number of projects from our armed services, including the US Army, as well as projects that covered offshore energy or renewable energy types of projects. Transportation isn't just for automotive, but also for maritime purposes or other modalities as well, and some of the security issues that come along with that. We also had a number of projects that were looking at supply chain risk or also interdependencies across different industries. When you think about potential for vertical takeoff and landing, there's both the aerospace domain of the actual vehicle, but then there's also the infrastructure domain of the landing port and associated energy requirements for that. Overall, our students all got their top 1 or 2 picks for projects. So it was something where everyone was able to pursue something they were very interested in. Here are just a few other topics from recent years. These include infrastructure projects, again, transportation projects. We have space-associated projects for looking for space debris, implementation of IoT for construction sites and manufacturing, as well as blockchain and other commerce-focused types of projects as well. I'm just going to quickly run through a number of examples that I mentioned from the last couple of years. Here you can see a project that was undertaken to look at ropeless elevator to really pursue how can we construct taller buildings that may be limited by the current technology stack for elevator systems. Starting in the top right corner, the students pursued a stakeholder value network to understand the interdependencies and relationships of the stakeholders and who they needed to deliver value to. And then they continued in the bottom left to pursue a trade space analysis to look at the trade-offs that exist in different architectural concepts that they developed, and potentially what the cases or the costs associated with those look like. As I mentioned earlier, we do pursue understanding of both risk and uncertainty throughout the full product life cycle. And you can see in the bottom right-hand corner that the students were investigating and analyzing risks and mitigations through the implementation of the design that they selected. Here, you can see a project from a little bit different domain. This was sponsored by the company Uber, who was pursuing different ways in which they could improve the safety and security of some of their new vehicles. These are not automotive vehicles, but you can see here we have a bicycle, and they're looking at how they can potentially detect or mitigate vandalism and other things. As you can see, the students were looking at the existing vehicle, and then they were pursuing how they may actually create new architectures based off of existing design decisions and new technologies. And from that, they were also then looking at how to integrate new technologies over time in their implementation plan. This project, again, in a little bit different domain, was investigating the potential for a distributed network of offshore energy in the Japanese maritime industry. As you can tell here, the students first started with a landscape review to understand what existing architectures may already be in place that they could learn from. From that, they also then pursued what were those key architectural decisions, and ultimately what choices could they make to potentially have different performance outcomes or costs associated with operating this new distributed energy network. From that, the team distilled their analysis into a number of final recommendations that they presented to their sponsor to pursue. This project looked to pursue alternative means for growing crops, in this case in a controlled environment. The team originally was pitched the concept of could you develop a vertical farm in an abandoned coal mine? And the team really investigated what the stakeholder needs were and pursued ultimately what might you be able to do in a rural or remote area that doesn't typically already have large amounts of agriculture. How could you potentially then balance the diet associated with the needs of the community and offset that with a certain amount of output from different architectures for this controlled environment farm. A stretch goal of this project was also then to look at potentially Mars colonies as another remote type of community. And so they were able to structure their design decisions in a way which they could potentially look at what that could be in the future. So the next 5 examples, I'm going to move through a little bit more quickly, but it's just to show you additional breadth and depth of these types of projects. This project here was actually pitched by an MIT startup. They were looking at bringing an alternative means to manage sanitation in developing countries. This project, they're looking to repurpose offshore platforms and how might you be able to utilize that existing installed base for renewable energy. This includes, a very significant technical analysis as well as a financial model to really understand when you might achieve return on investment or when you may be able to implement something like this based off of available technologies. This project, which was sponsored by Amazon Robotics a few years ago, was looking at how they could integrate new sensor sets into existing robotics and fulfillment centers to improve performance within their fulfillment center, but also work more collaboratively with the workers that were in the space. This project was a little bit different domain, looking at the next generation cooking coming from Whirlpool. And here they were really taking a full sort of life cycle view of not just cooking itself, but what are the processes that happen before and after, and ultimately what's the value that is trying to be created in this, and how might you be able to integrate and create interoperability between appliances within a kitchen to ultimately improve that experience. And lastly, another maritime project is looking at the series of stakeholders that operate in this industry, and where might you be able to actually achieve CO2 reduction across this whole stakeholder set, right? They may not necessarily operate together as an entity, but really across the entire industry. So now that we've gone through some examples and you have a sense of what the output might look like, let's talk a little bit about the expectations for the sponsor. So we're very much looking for our sponsors to be a guide to the students. The students don't necessarily come from the same industry or background that you do. So we're looking for you to be the voice of the challenge in this, right? To help provide context and perspective to the student team. At the same time, we're looking for you to also give the students some flexibility as they explore the problem space, and potentially even take it in a solution direction that you weren't necessarily anticipating. In addition to this, there is a level of communication that we expect for you to establish with the students based off of your and their schedule. But typically we see this at about once a week once we get into the actual semester from February to May. As I mentioned earlier, there's some key dates. The draft proposal is due around November 20th. We'll continue to work with you to refine this, but this we do look to have in November so that we can kind of have a little bit of dialogue about the topic. We will have our challenge showcase, which I mentioned will be virtual, the second week of January. And the spring term runs from February to May 2021. Final presentations, the dates are yet to be fully defined, but it will likely be the first or second week of May. Just a quick breakdown of the sponsor commitment. It's roughly about 24 hours over the course of the project. About 4 hours for prep and for pitching your challenge, but then about an hour per week once we get into the semester, and roughly 4 hours for review time for your final presentations with the student teams. We talked about the expectations for the sponsors, so what are the expectations for the student teams? Earlier, when I provided an introduction to MIT Systems Design and Management, I talked about the three key aspects of our core curriculum: system architecture, system engineering, and project management. And this is very much a demonstrative project for us to really assess what the students have learned and give them an opportunity to practice in each of these areas. So we're going to be looking for them to address aspects of SA, SE, and PM throughout their project, and really explain the choices that they're making in terms of how they're utilizing what they're learning. We also expect our mid-career professionals to also balance past experience with the new ways of thinking and methods that they have, although some of the approaches that they may have come into the program with could be beneficial to the project. There's going to be a number of different methodologies that are used, and some of these are going to be different from what you may have as internal processes or practices within your companies. So this is actually a really great learning opportunity for you as well. Okay, so we talked about what the Core Integrated Team Project is, as well as reviewed some examples. We've discussed what the expectations are for the sponsors as well as the student teams. So what's the next step if I'm interested in sponsoring a project and ultimately pitching it? On our website, you can download the template for the challenge submission. And as you can see here, there's general information and a little bit more detailed information that we're looking for. A project name and title, a logo of your organization, the challenge summary, which would be a brief introduction and overview of your company, and ultimately, what's the vision that you have for this challenge, and what's the value that you're really trying to gain from it. What of the 4 project types, which challenge objective are you pursuing? And note that sometimes it can be more than one. We're also looking for some project context, right? This will help our students get a sense of how this fits into your organization. What are the different types of technologies potentially that you're pursuing? Are there key uncertainties that they should be aware of, or maybe even existing projects or products? And what are some of the key priorities from your perspective that the student team should consider? On the right-hand side, sometimes it's helpful to include a diagram or maybe even a picture of the project that you have, or flowchart if it's decision-oriented. And lastly, on the bottom right-hand corner, we're looking for contact information for you, potentially some of your colleagues that may be involved. And if there's some key references, either websites or white papers, those are beneficial to have as well. So lastly, I just want to address a couple key questions that often come up. Sometimes the student teams need a data set from your organization to really dive into the problem. And that's really important to have available at the beginning of the project. So if your project scope requires an internal data set that may need to undergo review or become anonymous so that the students can work on it outside of an NDA, it's important to get started on that early, and we can work with you on that process. In addition to this, sometimes companies have more than one project proposal that they're interested in pursuing. And that's something that we actually encourage. It's beneficial if you have 2 to 3 potentially projects that you're interested in, and the students can really help you select as to which ones they'd like to engage in. Additionally, sometimes companies ask if they're able to pitch more than one challenge. And this is something that we actually see quite often. In total, it's probably not better to go more than 2 or 3, as that sometimes can dilute the chances that you have of somebody working on one of your high impact challenges. But we do see oftentimes that if a company pitches more than one challenge, that at least one of their projects will get selected by a student team. Now, if you have any other questions or comments as you're thinking about how to engage in this opportunity, please feel free to reach out. Just to quickly recap for you, here is the overview information that we have available. Our website that you can go to, sdm.mit.edu, spring-project-sponsors, will have comprehensive information available there. And then again, some of those key dates.